This slide shows a practical learning path to get started with the Zephyr RTOS, real-time operating system, often used in embedded systems. Let's break it down step by step in a hands-on manner. Installation and Blink. This is your first step in working with Zephyr RTOS. You install the necessary tools like Zephyr SDK, Python, West, Zephyr's meta tool, and toolchains. After the setup, you clone a sample Zephyr project and run a simple Blink example on a supported board, e.g., STM32, NRF52. This confirms your setup is working and gives a feel for the build flash run workflow using West. CMake. Zephyr uses CMake as its build system. You'll learn how CMake lists.txt files are structured and how they work with West. You'll also understand how to add your own source files, include directories, and libraries in the build process. Mastering this step is key to building modular and scalable projects. Kconfig is a configuration system used to enable or disable features in your application, much like how Linux kernel configurations work. You'll explore tools like menu config to toggle system settings, e.g., enabling UART, selecting the system clock, enabling shell, etc. These configurations generate .config files used at build time. Device tree. Zephyr uses device tree to abstract hardware details. You define your hardware, GPIO pins, UARTs, I2C devices, etc., in .dts files. It helps your code remain hardware independent. You'll learn the structure of nodes and properties and how they map to actual hardware. Device tree bindings are .yaml files that describe how to interpret nodes in the device tree. For example, a GPIO controller node must follow certain properties and structure. You'll explore how Zephyr uses bindings to validate and extract data from the device tree, and how this connects to drivers. Device driver. This section teaches you how to write a driver in Zephyr. A driver is a C module that interfaces with hardware. Zephyr uses macros to register drivers at different init levels, e.g., pre-kernel, post-kernel. You'll also learn how to bind your driver to a device tree node and interact with it using standard Zephyr APIs. OpenOCD and GDB. OpenOCD is used for flashing firmware and debugging via SWD JTAG. GDB allows source-level debugging. You'll learn how to connect your development board to OpenOCD, flash code, set breakpoints, inspect memory, and step through your code. This is crucial for diagnosing bugs and verifying behavior. Multithreading. Zephyr is a real-time OS, so it supports multiple threads. You'll learn how to create threads with kthread create function, set priorities, and define stacks. You'll also explore synchronization methods like semaphores, mutexes, and message queues to manage safe access to shared resources. Interrupts. You'll learn how to configure external and internal interrupts. Using macros like IRQ Connect and writing your own interrupt service routines, ISRs, you can respond to hardware events like button presses or sensor triggers. You'll also understand priority levels and interrupt latency. Graphics with LVGL, Light and Versatile Graphics Library, is integrated with Zephyr for building GUIs. You'll learn how to render buttons, charts, and sliders on displays like TFT or OLED using LVGL widgets. This is useful for applications like dashboards, touchscreens, or smart home devices. Wi-Fi and IoT. Zephyr supports networking stacks including TCP/IP, MQTT, and HTTP. You'll explore how to connect to Wi-Fi, on boards with ESP32, for instance, send data to a cloud service, and control devices remotely. You'll also use Zephyr's net APIs or external libraries for secure communication. Custom board. This is an advanced step where you port Zephyr to your own hardware. You'll create a board definition with its pin mapping, memory layout, and supported peripherals. You'll write your own .dts, kconfig, and defconfig files so that Zephyr recognizes your board just like any officially supported one. This slide is from the Introduction to Zephyr series by Shawn Hymel on the DigiKey YouTube channel. You can find the link in the description. Thank you. Meet you in the next video.